Here we are solving a problem having concepts like friction, conservation of momentum, one-dimensional motion. It's a problem with multiple concepts, right? Let us see what the problem is first. It is given that a man of mass 60 kilogram is sitting on a ice, pushed a block of mass 12 kilogram on the ice horizontally. Let's stop there for a while and try understanding what is the meaning of that, right? Here is an ice. So this is how we are trying to solve the problem. Here is an ice. Assume this is all the ice. There is a man. Here is a man. He is sitting on this ice. This is a man. Pushes a block of mass 12 kilograms. So he is pushing a block of mass. This is the mass. How much is that mass is? 12 kilogram. On the ice horizontally with a speed of. So he has given a speed to this. How much of that speed? He has given an initial velocity of 5 meter per second, right? The coefficient of friction between the man and ice. So this is a rough surface. Between them there is a coefficient of friction. And between the block and ice, between these two also it's a rough surface, there is a coefficient of friction. To make our calculation simple, both the values are being given as 0.2 itself, right? Of course, gravity is taken as 10. Now, let's try solving see what we can get from this data, right? So the first thing that you need to understand is when there is no external force acting on the system, here there is no external force. You can consider this man, this block and the ice as one system, then we can say there is no external force acting. They are all part of a system, right? There is no external force acting. Then the momentum is conserved, constant or conserved. That is, momentum of the man is equal to the momentum of the block itself. What's the momentum of the man? Mass of the man into velocity of the man. Of course, they move in opposite direction. Mass of the block and velocity of the block. Mass of the man is given to you as 60 kilogram. Velocity of the man we don't know. Mass of the block is given as 12 kilogram. Velocity given to that is at that instant is 5 meter per second. So 12 into 5 is 60 equal to 60 into velocity of the man. That implies velocity of the man is 1 meter per second. So the first point before we go into the problem that we need to understand is as the block moves forward with a velocity of 5 meter per second, man moves backward with a velocity of 1 meter per second. Because there is no external force, just to compensate the reaction, this man will move in a backward direction. Now, you want to calculate the distance between man and block when they come to rest. That means what? This block will come up to somewhere. So what's the new position of the problem, right? So black will move somewhere and finally stops. Man also moves somewhere and finally stops. What is the distance between these two is the kind of question that's being asked. For that, we need to find out by how much distance the block moves, by how much distance the man moves in opposite directions, right? So for example, first of all, what are the force acting on the block? On block, force acting is nothing but the frictional force. What is the formula for the frictional force? Mu into normal reaction is the force acting. So mu value is given to you in the problem 0.2. Normal reaction is nothing but that weight of that block, that is 12 into G. G value is 10. Is frictional force equal to force. Force is nothing but MA. M is 12. Mass of that block is being given for you as 12 into acceleration. So this 12 and 12 will cancel. In the other sense, what I mean to tell you is mu n equal to MA. Normal reaction is mg equal to ma. Mm cancels. Acceleration when the friction is acting in this case is A equal to mu g. Mu is 0.2, g value is 10. So what is this I have calculated is acceleration of block moving in a forward direction. Similarly, I can do the same for the man. On man also I can write the same. Force acting is frictional force. Mu into normal reaction is MA, where M is the mass of that man. Mu into normal reaction is weight of that man equal to MA. This and M also will cancel. The same is acting as on the block as well as the man. So acceleration of the man is also equal to mu into g, right? So acceleration of the man. So how much is that? Mu value is 0.2, g value is 10. So that's also 2 meter per second square, but both are moving in opposite direction, right? So block moves how much distance? I want to calculate motion of block. Using a formula, I can calculate v square minus u square equal to 2as. Block is finally going to stop. Initial velocity given to the block as per the problem is 5 meter per second square. Acceleration of the block we have already calculated as mu c, that is 2. This is the distance moved by the block. So minus 25 equal to 2 into 2, 4. Of course, we can write a minus sign there because it's moving in opposite direction. So distance moved by the block in the opposite direction is 25 by 4. That is 6 4 24. And then 10 is there. So 6.64 is 24. And then there is 10. 4 2s are 8. Yeah. Then 20. So distance moved by the block is 6.25 meter. Now we have to talk about the motion of the man also. Motion of a man using the same formula again. V square minus u square equal to 2as. Man is also going to stop. But the initial velocity of the man basing on the conservation of momentum we have calculated is only 1 square. A value again I will write minus 2 indicating an opposite direction. Distance moved by man. Then distance moved by the man is 1 by 4. That is 0.25 meters. So what we understand here is man moves forward one way, block moves the other way. Both of them moves by how much? Block moves 6.25 meter and man moves 1 by 4, that is 0.25 meter. So what's the total separation between them? Add both of them. 6.25 plus 0.25. So the total separation between them 6.25 plus 0.25, that is 6.5 meters. That's the distance of separation between them. This is how we have to solve the problem. So there are multiple concepts involved in solving the problem. First of all, no external force acting, therefore momentum is conserved, so velocity of the man is found out. Next, there is no other force acting, only frictional force. So basing on that, we have derived a formula. Frictional force is nothing but equal to acceleration due to the frictional force in both the cases as mu g. Then to solve the motion, we have used simply equations of motion in the case of both man and block. As we want the distance of separation, simply we have added both of them. That's how we have to solve the problem. Thank you for watching.